Good morning, good day class. Today we are going to study the complete factoring. I assume that you have already know how to factor starting from common monomial factoring up to the general trinomial. Okay, we have examples here 1 and 2 and still have 3 and 4. The first thing in complete factoring class is to see whether you have a common monomial factor. You must remove first the common monomial factor before proceeding to the other method of factoring, if that is possible. Okay, so let's have this one. We have 2x cubed and we have 4x squared and we have 48. This one is a trinomial, 1, 2, and 3. Now, we factor that one. Do we have a common monomial here? Start with the lowest number, 2. So we have 2 here. 4 has a 2 here. 48 has a 2 also. So we remove the 2 here. How about the x? We have an x here. x3, x squared, and x. Then we have x here. That is our common monomial factor of this polynomial or trinomial. Now, let's have the body of this one. We have minus here, and bracket. Let's start. 2 divided by 2 is 1. x3 divided by x is x squared. That's for the first one. Second, minus, you copy the minus here. 4 divided by 2 is 2. X squared divided by x is x to the first. X minus 48 divided by 2 is 24. X divided by x is 1. So we have this one. By common monomial factor, we have this one. Now, look at this trinomial here. Can you factor that one again? So you look here, that's minus, so it is plus and minus. Factors of 24, then you subtract, and then we get the 2. Okay? So let us factor because this one is factorable again. So we have to factor that one again because it's complete. When it is not yet done, you have to continue. So for 2x, I'm going to put 2x here. Don't leave this 2x. Okay? It always be there. Alright, then we factor this trinomial here. Right, what is the sign of this trinomial? It's negative here. So 1 is positive. 1 is negative. We get factors of 24. 1 times 24? No, it will become 23. 24 minus 1. We have 2 times 12? No, it will become 10. 3 times 8? No, it is 5. That is not 5. 4 times 6? 6 minus 4 is 2. Now it's 4 and 6. Where do you put the 6, which is the greater? You put that one on the negative, so this one is 6 and this one is 4. By the way, we forgot the x. Let's put the x here because that's x squared. X times x, x squared. No problem with that. So I have positive 4, negative 6. So we have negative 2x. Positive 4 times negative 6, negative 24. So this is our complete factor. Okay, let's have this one. This one is a binomial. And when we have a binomial, you know, it's the difference of perfect squares. This one is a perfect square, and this one is a perfect square also. Okay, let's factor this one. And now let's factor like here. So what's the sign here? It's the last term, it is negative. So expect a plus and a minus. Square root of this one, x to the 4th is x squared. And this one, of course, is x squared also. Square root of 16, it's 4. and this one is 4. Okay. Of the two here, class, only the minus or the difference can be factored. We cannot factor anymore if that one is plus. So what are we going to do here? Just copy this x squared plus 4. So we have x squared here plus 4. We can't factor this binomial anymore. And then this one is still factorable. So we factor that one again because this one is a perfect square and this one is also a perfect square. So we need to factor that one again. This is minus, so 1 is plus, 1 is minus. Factor of x squared, this one is x, this one is x. Factor of 4, square root of 4 is 2 and 2 here. So this is our final answer. Do not factor this one because this one is unfactorable. This is our final answer. Okay, class, example number 3. For number 3, this is a binomial. Do we have a common monomial factor here? Yes. We have a 3 here, we have a 3 here, so we have a 3. The highest common factor. What about the x? This one is x to the 9th, and this one is x to the 1st. So we remove that one, we choose the x here. Okay. Then we have this one. So we divide 3 by 3 is 1, x to the 9th, divided by x, will leave us x to the 8 here. Minus, minus, and 3x divided by 3x is 1. So we have difference. Is this a perfect square? Yes. Is this one a perfect square? Yes, also. So we can still factor this one because this one is minus. If this one is plus, we stop there. This is already our factor. You must include always the 3x, and then we are going to factor this one, and we know how to factor this one because this one is the easiest of all the factoring. 1 is plus. Can we have the minus here? Minus here. And we have a plus here on the other side. So you have to factor square root of x to the 8 is x to the 4th. And this one is also x to the 4th. About 1, it's 1. And this is 1. Okay. 1 times 1 is 1. Negative times positive is negative. Negative 1 plus 1, 0. No middle term, 0. Now, of these two, we can factor this minus but not the plus. We don't have the factor of the sum of two perfect squares. It's only the difference of perfect squares. So copy again the 3x. Don't forget the 3x. And then we factor this one. This one, we'll just copy this one later. So we have here again. Let's say minus first, and then plus this one is for this. And then we copy this one. X to the 4th plus 1. Just copy that one. Now for this one, square root of x to the 4th is x squared. Square root of 1 is 1. And copy x squared plus 1. Now in class, this perfect squares, they are perfect squares, but this one is plus. So we don't have the factor of this x squared plus 1, and also for this one. These two, they don't have the factor anymore. Now for this one, we still have 1. This is a perfect square, and we have the difference or a minus here. So we need to factor this one again. So copy this one. 3x, and then for this x squared minus 1 we have 2 plus and minus and plus. Copy this one, don't leave this one. X squared plus 1, and that one x to the 4th plus 1. Right, factor of x squared, x, and this one is also x. This one, square root of 1 is 1 and 1. So we have here the factored form of 3x squared 9 minus 3x. Okay, let's have number 4. For number 4, I will erase this one class. Okay. Okay. Now, what you observe here, class? X cubed, how many terms do you have here? 1, 2, 3, and 4. When we have 4, we have the factoring by grouping. And if we have 4, usually it is a common binomial factor exists. So here, let's try to copy again in brackets. So we have x cubed minus 9x here, and you see the plus here. And here is 2x squared minus 18. They are now in parentheses. So we group them into two, the first group and the second group. Now, in the first group, let's have the common monomial. And the common monomial here is what? Plus the x. So we have x here. What the number? We don't have. So, bracket. X cubed divided by x is x squared, and then minus 9x divided by x, cancel the x, equal to 1, and we have a 9 here. Okay, plus and plus, common factor here, 2 and 18, it's 2 here, and then what x? No, we don't have the x there. So 2 divided by 2 is 1, x squared. So we have x squared here, minus 18 divided by 2 is 9. Now, what do you see here, class? We have common binomial factor here, which is x squared minus 9. We have that one in the first group, we have also that one in the second group. So we remove that one, x squared here, minus 9. And then we have this one, the plus. The big one, the plus. First group, second group, plus the plus. So let's divide this one. When we divide this one by this, x squared minus 9 is equal to 1. So we have x plus so far plus. Okay, that one. We divide this one by this one, 1, x squared minus 9, 1. And then we have the 2 here. Okay. Now, can we still factor this one? Yes, this one. Because this one is a difference of perfect squares. This one is a perfect square. This one, 9, is also a perfect square. So we need to factor this one. So, we have this one. What about this one? We need to include that one also, or else our answer will be wrong. Okay, it's like that. This 2 is for the factor of this one. So we need the plus and the minus. X squared square root is x, square root of 9 is 3, and for this one we just copy, and we have the complete factored form of number 4. Okay, thank you class, and see you next time.